Hi everyone, my name is Pradyumn and today we'll discuss the solutions to AtCoder Regular Contest 212 which happened on 11 January 2026. So let's begin. The first problem was this one, 4 TSP. There's a complete graph with 4 vertices numbered from 1, 2, 3 and 4. You will now assign weights to each of the 6 edges. Each weight should be a positive integer and the sum of the 6 weights should be equal to k. More formally, you will use positive integers xij, where I is less than j, such that summation of xij is k, and assign weight xij to the edge connecting I and j. For this weighted graph g, let f of g be the minimum sum of edge weights in a cycle that passes through all vertices. Find the sum modulo this number of f of g over all possible graphs. Okay, so this statement is pretty simple. What it is saying is that we have a graph. Okay, we have a graph of 4 vertices, 1, 2, 3 and 4. Okay, let's say I number these like this, and it is a complete graph. Complete graph means that all the edges are connected, like all pairs of vertices are connected by an edge, right? So on this graph we have to basically consider all the graphs such that these edge weights, let's say this edge weight is a1, this is a2, okay, this is a3, this one is a4, this one is a5 and this one is a6. So basically we have to consider all the graphs such that this summation from I equal to 1 to 6 of ai, this should be equal to k, right? So k is given and we have to, out of all those graphs g, we have to find the sum of f of g, where f of g is what? It is the minimum sum of weights on a cycle of length 4. Okay, what is cycle of length 4? Cycle means a path, a closed path, like a closed loop which visits all the vertices exactly once, right? Like let's say this can be a path, like a cycle, right? Or let's say if I do like this, so this path also visits all 4 vertices, right? But we don't have to consider this path because it doesn't visit all the vertices, it doesn't visit this third vertex, right? We have to find the sum. Like f of g is defined as minimum sum of edge weights in a cycle that passes through all the vertices. Okay, so it has to be a cycle and it has to pass through all the vertices and it has to be minimum, right? So of course we will pass through each vertex only once. Like if we are doing it multiple times, then it will of course be more than minimum, like it won't be minimum, right? So we will only pass through each vertex only once, right? And they are telling us to find the sum of this f of g over all the graphs that have this sum of edge weights equal to k, right? So let's first think to ourselves that how can a cycle look like what are the different possibilities for a cycle, right? So for example, let me just increase the font size here. Let's say we can have this cycle which passes through 1, 2, 3 and 4 like this, okay, or we can have the clockwise cycle, but that doesn't matter because the sum of edge weights is same. Like in both the cases the sum of edge weights is a1 plus this a1 plus a4 plus a2 plus a3, right? So this is one possibility. Then it might be that we start from 1, then we go to 2. Then let's say if we had gone to 3, then there's only one option, like we cannot go back like this, right? We have to go here and then we have to go here, we cannot even go back like this. So this is already counted, right? So therefore from this 2, if we go like this and then we can't go here, so we have to go down and then we go here, so this is also one cycle, right? And for this cycle the sum of edge weights is what? It is a1 plus A6 plus A2 plus A5, right? So like in the first cycle you saw that we left these two edges, like the diagonal two edges, we did not take them in our loop, right? We had these four edges in our loop and not these two, right? But in the second cycle you saw that it looked like this, so we did not take these two edges, right? And third possibility is that like we go like this and like this, right? So in that case we will exclude these two edges. So for the sum for them would be A2 plus, sorry, not A2, A3 plus A6 plus A4 plus A5. Okay, and there are no other cycles possible other than these three. Okay, like if you can sort of think about like this, that we have to, like we have six edges, right? In this six edges, and we have to like choose four of them, right? Because we have to choose a cycle of length 4. So the only way we can do that is by excluding two edges, right? So which two can we leave? And I am saying that we have to leave the opposite edges, like either these two, or we have to leave these two, or we have to leave these two, right? So that is the thing. And so we have all of these three possible sums. Like for a complete graph having weights from A1 to A6, we can have these three possible minimum sums. And so our f value is just like the f of the graph would be just the minimum of these three values, right? Like these three values, I'll take the minimum of that, and that is our f of g, right? But how do I like compute the sum of this f of g over all the graphs having sum equal to k? That is the question now. So to make our lives easier, actually we can write these numbers as total minus what we left. Okay, like a1, a4, a2, a3. So in this we are not taking a5 and a6, right? Like if we have this cycle, then we took all the weights except for a5 and a6, right? So we can say that the like this value a1 plus a4 plus a2 plus a3 is basically equal to the total. Total means the sum of all a1 to a6 minus a5 plus a6, right? And if you remember, total is equal to k, right? Like in the question they have said that we have to count all the graphs such that the sum of edge weights is k, the input, right? So k minus a5 plus a6. This is one possibility if we leave the edges a5 and a6. Otherwise, if we leave like a3 and a4, so we have k minus a3 plus a4, and if we leave the edges a1 comma a2, so we have k minus a1 and a2, a1 plus a2, right? So we have these three possibilities for our f value, and we will take the minimum of that, right? So if I have these three quantities and I am subtracting them from k, so I have k minus something in each of these three values. I have k minus something. So if I want this entire number to be as small as possible, I will try that this something is as big as possible, right? So that if I subtract it from k, it becomes smaller. So basically I can write the minimum of k minus a1 plus a2 comma k minus a3 plus a4 comma k minus a5 plus a6. I can write this quantity as k minus maximum of these three values, like k minus max of a1 plus a2 comma a3 plus a4 comma a5 plus a6. Okay, so this is our f value. Like for a graph, this f of g is just this thing. Okay, I'll write it in a better handwriting so that you can refer to it again. So f of g is just equal to k minus max a1 plus a2 comma a3 plus a4 comma a5 plus a6. Okay, so this is the f of g. Okay, so we have to like consider all the possibilities of the array a1 to a6. Like we have to take all the possible different arrays from a1 to a6 such that this each ai is greater than equal to greater than equal to 1, and the summation of ai is equal to k. And we have to like over all the possibilities of this array, we have to find the sum of this f of g, this quantity, right? So how do we do that? So like if I visualize this like this, that like basically I have 6 blanks, right? I have an array of length 6, so let's say I have 6 blanks, and I have to fill these blanks in such a way that the sum is equal to k, right? So first of all, for this f of g, I can like I have broken this into two parts, right? This first term is k, and second term is minus max of these. So if I want to take the summation of f of g, I can simply distribute them, right? Like I can this k is independent of these a values, so I can simply write this summation of f of g as k into number of things, right? And then I have to like subtract the maximum and the summation of that. But actually this is not used, so I'll not go into it that much, but you can write this as that. Like this k is constant, so you can just deal with it separately and just find the sum of this maximum of these values. But anyways, so okay, we have these 6 elements like a1, a2, a3, a4, a5 and a6. So what they are saying is that the sum of these two numbers, the sum of these two numbers and the sum of these two numbers, whatever is the maximum in these three, I have to subtract that from k. So k minus maximum of whatever these three are, right? So essentially I have only 3 numbers. Do you see? Like even though I have 6 independent numbers, a1, a2, a3, a4, a5, a6, but actually what I am concerned with is only 3 numbers. That is a1 plus a2, a3 plus a4 and a5 plus a6, right? And also I know that the summation like a1 plus a2 plus a3 plus a4 plus a5 plus a6, this is equal to k. Like I also know this, right? Like what my point is that I have these 6 numbers from a1 to a6, but actually what I am concerned about is just these 3 numbers a1, a2, a3, a4 and a5, a6, and like what is the maximum among them, right? So actually I have only 3 independent numbers. Like let's say if k is 20, then if I have the values, let's say 2, 3, then 7, 6, okay, and 1, 1. So here this is 5, this is 13, and this is 2, right? So I have the sum as 20. So basically the maximum is 13 in this case, right? So I have 5, 13 and 2, right? But let's say here even if I had instead of 2, 3, if I had 1, 4, then also it would have been 5, 13 and 2, and it would have been the same for all my purposes. Like I just have to find the maximum of these 3 numbers, right? So I can deal with both of these cases, like 1, 4 or 2, 3 or 7, 6 and 6, 7 or maybe 5, 8, right? So I can deal with all of these cases in one go. Okay, like I just have to iterate over the sum of a1 comma a2. Okay, like let's say my sum of a1 comma a2 is some c1. Okay, like this is A1, A2, A3, A4, A5 and A6. So let's say A1 plus A2 is some C1, this is some C2 and this is some C3. So what my condition is that I want C1 plus C2 plus C3 equal to K, and my f of this value, f of C1 C3 is basically like f of G is basically K minus max of C1 C2 C3, right? And so I can simply iterate over these values of C1, C2 and C3, like, because the constraint on K is up to 5000 only, right? Up till 5000. So even O of K square will work, right? So O of K square works. So I have three different numbers having sum equal to K. So what I can do is I can iterate over the value of C1 and C2. And of course I'll get C3 as K minus C1 minus C2, right? So in like O of K square, I can iterate over all the possibilities for this triplet C1, C2, C3, C1, C2, C3. I can iterate over all possibilities of this triplet, right? And I can find the value of f as K minus max of this, right? And I can also find out that how many times this triplet will appear. Like, what I mean by that is, let's say if K equal to 8, okay, and if I consider a triplet that is 2, 3, 3, right? That is C1 is 2, C2 is 3 and C3 is 3. So like, using how many different A1, A2, A3, A4, A5, A6, like in the actual problem I have to count this, I have to take the sum over all A1, A2, A3, A4, A5, A6, right? So A1, A2, A3, A4, A5 and A6. So I have to take the sum over all of these. So like this 2, 3, 3 pair, I can make it in how many ways? I have to count that as well. So like, I know that A1 plus A2 is 2, so they have to be 1 and 1 each. Then this A3 plus A4, it is 3. So either A3 is 2, A4 is 1, or A3 is 1, A4 is 2. And then A5 plus A6 is equal to 3. So either A5 is 1, A6 is 2, or A5 is 2, A6 is 1, right? So actually, like, for A3, A4 I have 2 options, and for A5, A6 I have 2 options. So in total I have 2 into 2 into 1 actually, which is 4 options, right? That is 4 different arrays of A1 to A6 make up this triplet of C1 to C6, right? So basically I will add this, like, K, 8 minus max of, so max is 3, so K is 8, max is 3, so 5. So I will add this 5 4 times, because I will get this value 5, that is I'll get this triplet 4 times. If I iterate over all the possibilities, I'll get this triplet 4 times. So I will add this 5 4 times into my sum, right? So the main idea here is just that we have only 3 different numbers, and we can just iterate over all the pairs of all the triplets, all the possible triplets. That is, I will iterate over C1 and C2, so that is O of K square, and C3 I can just find as K minus C1 plus C2, right? And then I can just count that triplet C1 to C3, how many times it appears, right? Like this 2, 3, 3 appears 4 times. Like, it can be made using 4 different A1 to A6 arrays, right? So I will add its contribution, that I'll add this f value of 8 minus 3 4 times, right? I'll add this 5 4 times into my sum, okay, and that is the entire solution. So like, in general, if I have C1 to C3 value as LMN, like, let's say my C1 to C3 value is L, M, N, then the number of ways I can make it is what? Like, I want A1 plus A2 to be equal to L. I want A3 plus A4 to be equal to M, and I want A5 plus A6 to be equal to N, right? So like, okay, doing this how many ways? Like I want a1 and a2 to be positive, right? a1 and a2 to be greater than equal to 1. So either I'll have 1 comma l minus 1, or I'll have 2 comma l minus 2, and up to like something comma 1, right? So you can just count this, like this is 1 2 3 up to l minus 1, right? This is 1, here it is 2, l minus 2, l minus 1. So we have l minus 1 pairs, such that a1 plus a2 is equal to l. And similarly, for this a3 plus a4, I will have m minus 1, and for this I will have n minus 1. And so the total number of pairs, total number of 6 length arrays would be equal to l minus 1 into m minus 1 into n minus 1, right? So we can simply iterate over all these values of l, m, n, and we can add l minus 1, m minus 1, n minus 1 into k minus max of l comma m comma n, right? Where k is the sum of l, m, n, right? So that is the answer. I hope you understood this. If you didn't, I will. You can write a comment on the YouTube video. So I'll show the code for this. Okay, so we don't need these factorials. So this is the code. In k, c in k, answer equal to 0. So I have these two loops, nested for loops, which iterate over the value of c1 and c2 from 2 to k. Like the minimum value of c1 is 2, right? And c2 also it is 2. So I'll start I and j at 2, and I will iterate them such that I plus j plus something can be equal to k. So I plus j has to be less than equal to k minus 2, right? So actually I could end this at k minus 4 as well, but anyways, that doesn't really matter. So if I have I and j as this, so I can calculate the third value, which is l, that is k minus I minus j, because their sum has to be k, right? And then in my answer I will add I minus 1 into j minus 1 into l minus 1 into the f of g, right? Like this I, j, l triplet occurs this many times, right? And into f of g value. So the contribution of f of g value would be this much. So I'll multiply them and add it to my answer, and then print the answer. Okay. So this was the problem number 1. Now let's move on to B now, which is called stones on grid. There is a grid with n rows and n columns. N rows and n columns. The cell at the ith row from the top and jth column is called ij. You perform the following in order of 1 to m. Operation I. Choose either to place one stone on cell xy or not. If you place a stone, a cost of ci is incurred. Otherwise, no cost is incurred. However, you must place a stone in operation 1. Determine whether the following goal can be achieved, and if it can, find the minimum sum of costs incurred. For every I from 1 to n, the number of stones placed in the ith row is equal to the number of stones placed in the ith column. Okay, so basically we have a grid. Okay, we have a grid which is of size n cross n. So it is a square grid, let's say 5 by 5, or let's say 4 by 4. Like I'll show this sample. This sample input 1, I'll just show it. So let's say we have a 4 by 4 grid, 1, 2, 3 and 4, and 1, 2, 3 and 4. So let's say like we have these 5 options, that is 2, 4, 5, 4, 1, 2, 2, 1, 3, 3, 3, 9 and 1, 2, 4. So what this means is that let's say the first operation, so we can put a stone at row 2 column 4, like at 2 comma 4 at a cost of 5, right? Like we can choose to either put or not put, but yeah, in the first operation we have to put the stone. Okay, so this 2, 4, 5 is compulsory. So we have to put a stone in row 2 column 4. Okay, so we put a stone here, and the cost currently is 5, right? Then we may or may not put a stone on 4 1 2, like we on 4 comma 1, so row 4 column number 1. So either we can choose to put a stone here or not, and if we choose to put a stone here, it will cost us 2 coins. So let's say we put a stone here, then 2 1 3, that is we can choose to put or not put a stone here. So let's say I choose not to do that. Then okay, my current cost is 5 plus 2, by the way. This second stone costed me 2 coins. Then 3 3 9, so let's say I don't put a stone on this as well. Okay, and 1 2 4, let's say I put a stone on 1, like 1 comma 2, so here, right? So it will cost me 4 coins, right? So total cost is 11. And as you can see that for each row and column, like the number of stones in column 1 is equal to number of stones in row 1, that is 1. Then number of stones column 2 is 1, and row 2 also it is only 1 stone. Then column 3 is empty, row 0 is also empty, and column 4 has 1 stone, column 4 has 1 stone, and row 4 also has 1 stone. So for all I, the number of stones in column I is equal to number of stones in row I, right? So this is satisfied, and we have done it at a cost of 11. So we have to find out the minimum possible cost to like fill this grid, right? So like how do we do that? That's the question now, that how do we actually find the minimum cost. Okay, so this sample is pretty good. Like we can actually start our thinking just based on the sample only. Now yeah, first of all, since this operation number 1 is like, what do you call it, compulsory, so we can't do like just don't put any stones at all. Like one thought would be that what if we just don't put any stones? So in that case cost would be 0, and all the rows and columns would have 0 coins, so 0 stones I mean, and so it is balanced, so the cost is 0 and the answer is 0. But this is not allowed because we have to place the first stone, right? So on 2 comma 4 we have to place a stone, right? Okay, then the thing is that okay, since I placed a stone on row 2 and column 4, I will need to ensure that like now this row 2 is unbalanced and column 4 is unbalanced, right? Like I will call I as balanced if number of stones in column I is equal to number of stones in row I. Okay, so like right now 1 and 3 are balanced, like the number of stones in column 1 is equal to number of stones in row 1, right? I mean row 1 and column 1 both are equal to 0. Then row 3 and column 3 both are equal to 0. But row 2 and column 2, they are not equal. Like in row 2 I have 1 stone, but in column 2 I have 0 stones. So it is unbalanced right now. And in row 4 I have 0, but column 4 I have 1. So it is unbalanced. So like 2 and 4 right now, they are unbalanced, right? So I'll need to like add a few more stones in order to fix that, right? So now like how do I add more stones? Actually what you can think about it, like you can actually think about this problem as selecting a few stones. Okay, like you can select a few stones, but in such a way that the first number, let's say this is the input, right? I'll copy this. So this is the input. So let's say you choose this stone, you have to choose this stone, then you choose this stone also, and you choose this stone also. So this like this choosing, like this choice of stones, it is valid because basically the row set, that is 1 comma 2 comma 4, is same as this column set. 2 comma 4 comma 1. Like this is also 1 2 and 4, and this is also 1 2 and 4. So basically the multiset of these, both of these, is equal. Okay, that is the thing. So therefore this choice of set of stones is legal, right? And the minimum cost is 5 plus 2 plus 4, which is 11. So like for each thing in the row, like you have selected 2 comma 4 comma 5 initially, right? So like in the row you have a 2, right? So in the column also you must have a 2 corresponding to this 2. Like for each 2 in the row you must have 1 2 in the column. So like if there are multiple 2s, let's say if I have 2 4 as well and I have 2 5 as well, so in my columns, like in my row I have 2 2s, right? So in my column as well I have to have 2 2s, right? They might be of, like, yeah, so in this case 2 is balanced, but let's say it is 3 2 and it is 4 2. So now 4 is balanced, but this 3 and 5 are not balanced now. So if I have one more stone which is 5 comma 3, so now this entire thing is balanced because I have 2 2s on the row, 2 2s on the column, then a single 3 on the row, single 3 on the column, single 4, and single 5, single 5, right? So basically for every 2 I can have a corresponding pair in the columns. For every 2 in the row I have a corresponding pair in the columns, right? So you can kind of make a path out of this. Like what I mean by that is, let's say you have this input, right? You have this 2 4 4 1 and 1 2. So like initially you have only 2 4, right? You have only 2 4, so you inserted that into your set. Like okay, let's say initially it is empty, right? Like the set of chosen stones is empty. Okay, then let's say you choose this 2 4 5. You have to do that, right? So you choose this 2 4 5. So like now you have 2 and 4, right? So for now just forget about this 2, but look at this 4. So adding this 4 did what? Like now you have a 4 in your columns but not in your rows, right? You have a 4 in your columns now but not in your rows. So now you will have to choose a stone which has a 4 in its row, right? So let's say you choose 4 1, right? So now these 4 and 4 are matched, but now we have a 1 in the column, so we'll have to choose a 1 in the row. So let's say we'll choose 1 comma 2, right? And then since this 2 and 2 are same, we have reached the end, and voila, like that's great, right? Like if you can understand that what I am doing is, initially this 2 comma 4 is compulsory, right? Now since I have a 4 in the columns, I have to have a 4 in the row as well. So I will have to choose a stone which is 4 comma something, right? So let's say if I choose 4 comma 1, so 4 comma 1 is there. So now I have a 1 here, and so I'll have to keep a stone at 1 also. Like since 1 is in my columns, I'll have to keep a stone of 1 in my rows, and coincidentally I got a 2 here, and since I got a 2 here, I don't need one more 2 and something else because I already have an extra 2 right in the beginning, right? So I can stop at this point. Okay, this is the kind of idea that I am using here. But so like essentially you have a path, right? Like this 2 comma 4, like you can think of it like you have 2 4 here, so there's an edge from 2 to 4, and 4 and 4 is same only, right? So you reached, like from 2 you reached 4, then from 4 you reached 1, then from 1 you reached 2, right? And then the loop is complete. You have to finally reach 2 only. Okay, so like this is the kind of idea that we can do. Like we have n rows and n columns, right? We have n rows and n columns, so we can think of a graph having like n vertices. Okay, like if you understand, that we start at the vertex 2. Actually, we start at vertex 4. Okay, then we find out all the adjacencies from vertex 4. So we go to vertex 1. Then from vertex 1, we find all the edges, and then we go to vertex 2. And since our goal was vertex 2, our goal is complete. Like basically what I'm saying is you can model this entire thing as a graph. Okay, like how? Basically you can think of n nodes. Okay, like this input I'll model as a graph. Okay, just look at this thing, this idea here, that we have a kind of path here, right? From 2 to 4, then from 4 to 1, then from 1 to 2, and we end up at 2. So that is correct. So kind of we can model this as a graph. Like 2 4 means I have an edge from 2 to 4. Okay, let's say like here there are 4 nodes, right? So I will draw a graph of having 4 nodes. So 1 2 3 and 4. So 2 comma 4 means I have an edge from 2 to 4. Then 4 comma 1 means I have an edge from 4 to 1. Okay, let's add the weight also. So 2 4 वाले edge का weight 5, 4 1 edge weight is 2, then 2 1 edge weight is 3. Okay, then 3 3 we have an edge from 3 to 3 whose weight is 9, and then I have an edge from 1 to 2, 1 to 2. Okay, whose weight is 4, right? And basically what they are saying is that this 2 4 edge we have to traverse, right? Like we start from 2. Basically this first edge you have to traverse. This first edge is compulsory. So we have to traverse this edge right here. And then we have to find a path on this graph such that we end up on 2 again, right? We have to close this loop exactly. So we can go up like this through this edge, and then through this edge we can go again to 2, right? So like on this graph we have to find the shortest path which ends in 2 basically. Did you understand this, guys? Like I just modeled this entire problem in terms of a graph, right? Like every solution that I can get which has balanced rows and columns, that just means that each row appears exactly once and each column, I mean no, like each time a row appears, a column also has to appear, and each time a column appears, a row also has to appear. So basically I can think of it like a cycle. Like see, if I am going from 2 to 4, like in a graph if you see, let's make a random graph. Okay, let's say this is the graph, and I'll number the nodes 1 2 3 4 5 and 6. So let's say in this graph, if you take the path which is like this 1 2 6 5 2, okay, let's not start with 1, let's start with this 2 3 4 5 and 2. So the edges that you took, like what are the edges that you took? You took 2 comma 3, then you took 3 comma 4, then you took 4 comma 5, and then again you came back to 5 comma 2. So basically you left like the number of times you entered a vertex like this 3 you entered once, and you went out of it also once. So like through this edge you entered the 3, and through this edge you exited the 3. So for any cycle in the graph, like if you have any path which starts and ends at the same node, it will have the same number of entries and exits for some node. That is, this 3 will come equal number of times in the right side and the left side, and that is what we want in our problem, right? And that is the idea of this problem, that we can like boil this down into a graph problem, and we can just solve it then, right? Like I can write this input as the edges. Like 2 4 5 means I have an edge from 2 to 4, having weight 5. Like I will model it like that. Okay. And then 4 1 2 means I have a edge from 4 to 1 having weight 2, and so on. I'll draw all the 5 edges, and they are saying that we have to take this edge, right? So we are at index 4 right now, and we have to reach 2 somehow. So basically I have to find the shortest path from 4 to 2, right? And that is just this path, this from here. So 2 plus 4, which is 6, and this initial cost 5, so 6 plus 5 11, so 11 is the answer. So that is what we can do. We have to like just boil down this problem into a graph problem. Okay, and why it works is because any solution that I can get from here, I can convert it into a graph, and any path from a graph that I get, like any closed loop, I can convert that into these edges, right? Provided that the edges don't repeat, right? Because we can only use each stone only once, but of course in the shortest path the edges won't repeat. So that is the solution. Like we can simply draw these edges, make it into a graph, and find the shortest path. Like to be particular, I can show you how this works. Like what I'm saying is that okay, the first edge is compulsory, right? So what you can do is you can start from this node 4. Like you can start your Dijkstra from this node 4, and you have to end up here, right? So because you have already taken this edge, so you can start your Dijkstra from this node and find out the shortest distance to this node 2. Okay, so if the first edge is 2, 4, so you will start at 4 and end at 2. Okay, so let me just show the code for this. Now actually the code that I had written during the contest, it was more complicated than this. Like my logic was a bit more complicated, and it was not necessary at all. And while explaining this to you, I came up with this different type of code. So I will just write that out right now, and I'll show you it. Okay, so let's write that code. So okay, we have int nm. Let's take long nm. Scene nm, and then we'll keep a vector which is adjacency list. Of n size. Then we have m edges, and let us mark the starting point and ending point. So actually we can let's just not add this edge into our graph. Like this first edge, we will not add it to the adjacency list because it doesn't really matter. We won't even use it, right? So vector of vector, start end, and the final answer. So like what I'll do is I'll scene end, start, and ans. So do you understand what I did there? Like this first 3 numbers, 2, 4, and 5. So this is the ending vertex 2, starting vertex is 4, and the cost is 5. Like I'm just storing this initial 5. Okay, and I am having here 0 index, so I'll keep it 1 index. Okay, then I have more m-1 edges. So for f I comma m-1, so for int I equal to 0, I less than m-1, I plus plus, I will take the input LLAB ABC. My typing is very slow right now. Okay, scene ABC, adjacent of A dot pushback B comma C, adjacent of B dot pushback A comma C. Right, this is the okay. Actually, this is the only thing. The edges are directed, right? This is a directed graph. So adjacent of it dot pushback B comma C, and then we can start a Dijkstra. So I'll copy the code for the Dijkstra from CP algorithms. Like even though I know how to write it, but I'll probably mess up because I am recording right now. So let us copy the code for Dijkstra on sparse graphs. So this is the function. I'll just define int long long. Okay. First of all, define int long long as well. And I'll remove this INF. Okay. And I'll increase this thing. Okay. And also, yeah, so I'll just call this Dijkstra function. So what is this P? Like it is taking two. Acha, okay. It returns the path as well. We don't care about that. Okay. And it is 0 index actually. It is 0 indexed from 1 index. It is 0 indexed. But it doesn't really matter, I guess. Yeah, it doesn't matter. So I'll call the Dijkstra function with my two vectors. Adjacency list. Okay, source. So start at this node. So adjacency list is not taken in this code. So they are using a global adjacency list. So I'll make it global. This is kind of weird. Okay, they have already defined it. So I will change. I'll simply do adjacent dot resize n+1. Okay. So Dijkstra and start D and P. So this D of n will contain an answer. So yeah, if D of n is equal to infinity, then Cout -1, right? Like if there is no path from this start to end, then Cout -1. Otherwise, Cout D of n plus the initial weight. Okay. D of n plus ans. Right. So this is the code, and I'll test it also. So in my input.txt, I will add the input. And I'll run the code.cpp. Okay, compression error. What is the error? Main must return int. Okay, let's make it signed because we used define int long long, so that's why it happened. My laptop is too slow, to be honest. I guess I'll have to change it one day. I hope it is recording. Yeah. 11. Yeah, so 11 is coming. Then I'll test it on this input also. Yeah, so this is the correct answer, and on this I should get -1. So -1 is coming. Okay, so I'll submit this in front of you guys. But this infinity value, I hope it is large enough. I'll add more zeros to it. How many zeros there are? 18 zeros. Okay, that is fine. So I'll submit this. Okay, I guess it got AC. So yeah, the main idea was that we can make this graph, and we'll start at this node 4 and find the shortest path to this 2 node, like this node, right? And if it exists, then that is our answer, like from here plus this 5 initial. Okay, that is the problem. It was a nice problem, like we had to reduce this into a graph problem, so it is a nice idea. Then let's move on to the next C problem now. Absolute ball. There are n white balls. First you paint each ball red or blue. Then you place these n red or blue balls in one of m different boxes, or m distinguishable boxes. Let ai and bi be the number of red and blue balls in the ith box respectively. Find the sum modulo this number of product from 1 to m of mod of ai minus bi over all the ways to place the balls. Here two ways of placing the balls are different if and only if at least one of ai and bi is different for some I. Particularly, balls are not different from each other. Okay, so alright, so what they are saying is that we have like n balls, right? We have a total of n balls, and we can color them either red or blue, right? So let's say we colored x balls red and y balls blue, and then we have to put them in boxes. Like we have m different boxes numbered from 1 to m, and basically let's say in the ith box we place ai red balls and bi blue balls, right? So that means that the total sum of these numbers should be equal to n that they are given, right? So in the ith box we put ai red balls and bi blue balls, and we have to find out the product. Like we have to find out this quantity, mod of ai minus bi, like the product of this from I equal to 1 to m. Okay, like ai minus bi ka product. So like basically mod of a1 minus b1 mod into mod of a2 minus b2, and so on up to mod of am minus bm. Okay, so we have to find this out, this product, and we have to find the sum of this product. Like basically there are many ways to place these n balls, right? Like there are many ways to paint these n balls as well into red and blue, and to place them in different boxes there are different ways, right? And so over all the ways we have to find the sum of this quantity. Okay, and that is the problem. All right, so let us think about what we can do. Okay, so first of all just look at the expression. All right, like the expression is what? The product from I equal to 1 to m of modulus ai minus bi. So what is this mod? Why is this mod required? Like basically sometimes it might happen that ai is less than bi, right? So actually let's say it is 3 and 5. So in the product they want that we should have 2. Okay, 2 into something, right? Not minus 2, because if it is minus 2, and like in this product if there are odd number of minus, like if there are odd number of terms having negative sign, then we might have the sum as less than 0, right? So if we like find the total sum it might happen that the negative and the positive cancel out, right? So what they have done is just added mod to every term, right? But actually the thing is that we don't need to add mod to every term, right? Like we can simply take the mod of the entire thing, right? And even that is sufficient. Like instead of writing mod of a1 minus b1, into mod of a2 minus b2 up till mod of an minus bn. I can simply write this as the entire mod of a1 minus b1 into a2 minus b2 up till an minus bn. Right, I can write the mod like this. Okay, this is the thing. So I have to find the sum of this quantity over all distributions of ai bi, right? Like over all the ways to distribute this into ai bi such that a1 plus a2 plus up till an plus b1 plus b2 up till bn, bm, it should be m here, m, okay, there are m boxes, so up till bm, here am, should be equal to n. Like basically in the ith box I have ai red balls, bi blue balls, so and the total number of balls that is given, there are n, so I want to have the total number of balls equal to n. So this is the condition, and I can basically break this n into a1 plus up to am and b1 up to bm, and I have to find the sum of this quantity over all the combinations, like over all the ways to break this n. Okay, so this is the main problem, right? So like there are many different ways to break this n into like a1 till an and b2 till bm, right? And yeah, they have to be non-negative, like these ai and bi have to be greater than or equal to 0, right? So basically if you know some PNC, there are a total of n plus 2m minus 1 c2m minus 1 ways to distribute this n into 2m like 2m numbers such that they are greater than or equal to 0. So there are these many number of ways. Like even if you don't know this fact, I will show it because it is a big part of this problem. So but if you know it, then this is the different number of ways to distribute this n is equal to this value, right? And so over all the different ways we have to find the sum of this product. So now what can we do? So there is one more observation here that I can tell you using an example. Okay, like let's say I have n equals to 5 and m equals to 3. Okay, so just consider one way of breaking this. Like I have 5 balls, right? So let's say one way of breaking this is, let's say in the first box I have 2 and 1, right? In the second box I have 1 and 0, and in the third box I have 0 and 1. So in total I have like 3 boxes and like 5 balls, 2 plus 1, 3 plus 1, 4 plus 1, 5. So this is one way of breaking this 5 balls into 3 boxes, right? So for this combination, what is the value of the product? So it is basically 2 minus 1 into 1 minus 0 into 0 minus 1 and the mod of that. So like basically what we have is 1, right? Like 1 into minus 1, so we have minus 1 and we take the mod of that, so we have 1, right? So yeah, so this is one of the possible ways to break it, right? But now what I tell you is, like, okay, first of all, if any of them is equal, like in these m terms, or in this case 3 terms, if any ai is equal to bi, that is, let's say if here it was 2 2 instead of 2 1, then of course the product would be 0. The product would turn out to be 0, and if we add it to our sum, it won't do anything, right? So like we don't care about the combinations which have some ai equal to bi, like because they don't contribute to our sum, right? So we'll now consider that ai is not equal to bi. Like we'll just find out the number of, we'll just consider all the pairs where ai is not equal to bi. Okay, we'll just consider all the distributions such that a is not equal to bi, and then find the sum of the product over that over these values. Okay, so we have boiled down that ai is not equal to bi. So yeah, in this case ai is not equal to bi, so we have a non-zero sum. So this is one distribution, one way to distribute. But now let's say instead of 2 1, I have this 1 2. Okay, and rest of these two I have the same. Okay, so in this case, what is the product? It is basically absolute value of 1 minus 2 into 1 minus 0 into 0 minus 1. So minus 1 into 1 into minus 1, which is 1, right? So it is turning out to be 1. Like here also it was 1. It was 2 minus 1, 1 minus 0, 0 minus 1. So it is minus 1 and the mod is 1. So like these two are coming out to be same. And obviously, right, it is obviously same because I just swapped this 2 comma 1 for 1 comma 2. So like I just swapped ai and bi, right? But in the product it was the product of ai minus bi, and we also had a final absolute value, right? So the sign doesn't matter. So even if I have ai minus bi or if I have bi minus ai, the product will turn out to be same, right? Like if I know the answer to this combination 2 1 1 0 0 1, then actually I can swap any of these m boxes. Like if I know the answer to this, like if I have the product for this case, then I can swap this one or this one or this one, or maybe these two even, or these two or these two, or all of them I can swap. So basically I can swap any of the three boxes that I like, and the answer will still remain 1, right? So basically I have like 2 to the power 3 possibilities, right? Like either I can swap this one or not, or this one I can swap this one or not, or I can swap this one or not. Like what I am saying is that there are in total of 2 to the power 3 combinations which are similar to this. Okay, and what I mean by similar is that if I can swap ai and bi in any of the boxes, then it is similar. Okay, like this 1 comma 2, 1 comma 0 and 1 comma 0. So this is also similar to the above one. Like these two are similar. Why? Because this ai comma bi is same for all i. Like I have 1 2 and 1 2, 0 1 0 1 and 0 1 0 1. So in total there would be 8 of these, right? Because for each box I have an option to either keep it increasing order like 1 comma 2, or I can give it decreasing order 2 comma 1. So for each box I have two options and I have total m boxes. So in total I have 2 to the power m different arrangements which are similar, like which will give the same answer, right? They will all give me answer 1. Okay, so actually what I can just do is maybe I will not look at all of these different 2 to the power m possibilities. I will only look at one of them. Like I will take the sum of only one of them and then I will multiply it by 2 to the power m at the end. Okay, like do you understand? Like here, if I want to find the answer for n equal to 5, m equal to 3, so one way is to break it like this, right? Like 2 1, like see, this if n is equal to 5 and m is equal to 3, then one way is to break it like 2 1 1 0 0 1, right? So actually this is not one way, it contains 8 different ways, because I can swap these two, I can swap these two, I can swap these two as well. So this thing has 8 different ways. So actually in my sum the contribution would be 8 into 1, right? So I will add 8 into 1 into my sum, or in general 2 to the power m into the product that I can get, right? So this is one way, like to break 5 into 3. This is one way. One more way could be like, let's say 0 comma 0. Okay, this will give 0 only, right? So let's say we have 1 comma 1 or 1 comma 0. Okay, then we have 3 comma 0 and then we have 1 comma 0. So this is also one way. Like we have basically 1 plus 3 plus 1, which is 5, right? We have 5 balls and we break this like this. So this will also give a product of 3, right? Then one more way could be to break it into 3 comma 0, 1 comma 0 and 1 comma 0. So this is also one way, and like this is a different way. Like I am not calling this way and this way as similar. Okay, like I am calling two ways similar only if I can swap the AI and BI. Okay, like this would be similar to 1 0, 0 comma 3 and 1 comma 0. So if I have 1 comma 0, 0 comma 3, 1 comma 0, then I call them similar. But if the order is different, like here 3 0, like in this one 3 0 was here, but in this one 3 0 is here, so I am counting them differently. Okay, so this is also another way, and this will give 3. And so I can just iterate over all the different ways to like break this. I can iterate over all different ways to break this such that I only count them once, right? And I'll take the sum of them and then I'll multiply it by 2 to the power m to get the final answer, right? So now like basically for a given this, like a basic thing, I have 2 to the power m different pairs, right? So like for the first box I have either smaller and then higher, like 1 comma 2 or 2 comma 1. Then second box I have 1 comma, like I have 1 comma 0 or 0 comma 1. So for each box I have either small high, like small large or large small. So I have two options for each box. So I'll have 2 to the power m different similar distributions, right? So what I'll assume is, like in my basic case, I'll assume that AI is less than BI. Okay, like if I just count the number of different possibilities where AI is less than BI, then I can, like I won't have the repeating case. See, in the original problem, in the actual problem, we have, let's say, n equal to 5 and m equal to 3, and we wanted to like break it into AI and BI, A1 B1, A1 B1, A2 B2, up to AN BM or AM BM, right? Such that the total sum of these balls, A1 plus B1 plus A2 plus B2 up to AM plus BM, this should be equal to n, right? And there are no other conditions, and so we have to like iterate over all the different possibilities with some up to n, and we have to find out the like that product mod of A1 minus B1 right? So in the actual problem I have to iterate over all the different possibilities of AI BI, but what I am saying is, let me just iterate over all different possibilities where AI is less than BI. Okay, like basically for this n equal to 5 and m equal to 3, this won't be a valid possibility, but corresponding to this I will have a possibility of, let's say, 2, like 1 comma 2, 0 comma 1 and 0 comma 1. So I will have this possibility and I will count the answer to it as 1, and I'll multiply it by 2 to the power 3, because there are a total of 2 to the power 3 ways that I can derive from this. So actually if I find the answer for AI less than BI, then it will only give me these basic ones like 1 comma 2, 0 comma 1, 0 comma 1, or 0 comma 1, 0 comma 3, 0 comma 1. And then finally, like I can find the answer for this case, like I can only consider these options of breaking, and then I will multiply it by 2 to the power m to get my final answer. Okay, so again I'll repeat. What I am saying is, let's say the answer for my original problem is equal to x. Okay, so in my original problem what I had, that the condition is just a1 plus b1 up till am plus bm, this should be equal to n. This is my condition. in the actual problem. But in my problem, in my derived problem, the condition is that first, this is also the condition that a1 plus b1 up till am plus bm, this should be equal to n. That is fine. But I also have that for each I, ai should be less than bi, right? So I have to find the sum of product in this case. So let's say the answer for my problem is y. Okay, the answer for the actual problem is x and my problem is y. Then I am saying that x is equal to 2 to the power m into y. Okay, because for each pair in my problem, I'll have corresponding 2 to the power m pairs for the original problem. So and the value of them would be same. So I can multiply the sum by 2 to the power m. Okay, so this is fine. So now the problem is boiled down to, we have to count the number of we have to find the product such that ai is less than bi. Okay, we have one more condition now, that ai is less than bi. So okay, what we had, the sum that we had was product of a1 minus b1 into a2 minus b2 up till am minus bm, right? And thus basically the summation, like a1 plus b1 plus a2 plus b2 up till am plus bm is equal to n, and also ai is less than bi. So for these two conditions, I have to find the sum of this product. And so since ai is less than bi, let's assume that the difference bi minus ai is some d. Okay, let's say bi minus ai is some di. Okay, so I can write this as like minus di, right? This ai minus bi is minus di, or I can just write di because this absolute value will just eat the minus, right? So I can write this product as product of d1 into d2 into d3 up to dm, right? And if I have written this bi, I have written this bi minus ai as di. So what I can get is bi is equal to di plus ai, right? And here all the di's have to be greater than 1. Like since ai is less than bi, I can write bi minus ai as di, where di is positive. So di should be greater than 1, right? So I can replace this bi minus ai with di, so I can get this product. And my condition, like this condition, I will rewrite this in terms of a and d, right? So this a1 is a1 is fine, but b1 is equal to a1 plus d, a1 plus d1 I think, then a2 plus d2, okay, and so on until am plus dm, right? And this I want to be equal to n, right? And also I want that the ai's are greater than equal to 0 and the di's are greater than equal to 1. Okay, and then so now I can write this as, I can rewrite this as 2 into summation of ai plus summation of di should be equal to n, where the ai's are greater than equal to 0 and the di's are greater than equal to 1. So this is the condition now. The condition has boiled down to this, and I have to find the product of di. Like if this is the condition, then over all ways to divide this n, into ai's and di's, such that twice the sum of ai plus sum of di is equal to n, I have to find the product of di and take the sum of that over all the ways, right? Like for example, if I have n equal to 5 and again m equal to 3. So I have to, like, I have a1 d1, I have a2 d2, and I have a3 d3. So I have to choose an a and a d such that this sum is equal to n, right? And the value for that distribution is the product d1 d2 d3. And over all the distributions, I have to find this product d1 into d2 into d3 and take the sum of that, right? So this is the thing now. Now the main idea is that since n is given to be like 1 is 7, right? The constraints on n and m are equal to 1 is 7, right? So actually I'll try to iterate over some quantity, right? Like here it is given that my condition is that 2 into summation ai plus summation di is equal to n, such that this is ais are greater than equal to 0 and di's are greater than equal to 1, right? So what I'll do is I will count the sum if summation ai is sum equal to x. Like what I'll do is I'll assume that this summation ai is equal to sum x, okay, and find the answer for that in terms of x, okay, and then I'll iterate over all the x's, okay. So that is my idea. Like I will fix this summation of ai to be some x. Alright. So what I get here is 2x plus summation di is equal to n. So that means that the summation of di is equal to n minus 2x. Right. So now there are two questions. That in how many ways can this summation ai be equal to x? That is a1 plus a2 plus up till am, I want it to be equal to x. So in how many ways can that be done? That is one question. And one more question is that if my summation of di is n minus 2x, then what is the sum of the products of di? Right? These two are the questions that we want to answer. Okay, like this is my problem. Basically we have to see if the summation of ai is equal to x, we are assuming that, like, originally what we want to do is over all the ways to distribute n into ais and di's such that 2 into sum of ai plus sum of di is equal to n, we have to find out the sum of product of di's. That is our problem, right? So basically we have many terms. Like I'll give an example. Let's say n equals to 5 and m equals to 2. So we have an a1, I have a d1, I have an a2, I have a d2. So I need to have this a1 a2 as greater than equal to 0 and d1 a2 as greater than equal to 1. And twice a1 plus twice a2 plus d1 plus d2 should be equal to 5. So one possibility is that maybe I can have 1 comma 0 comma 2 comma 1. Okay, d1 can't be 0, sorry, my bad. So 1 comma 1, and let's say this is not satisfying. Let's say 0 comma 2. Okay, this is one possibility of this. So like 2 into 1, this is 2 plus 0 plus 1 plus 2, which is 5. So this is one possibility of breaking. Then another possibility of breaking is what? Let's say if we have 0 1 and 1 2. So this also gives us sum equal to 5, right? Then maybe what we can have is 1. Okay, maybe we can have 0 0 and 2 3, or maybe we can have 0 0 and 3, 2. And so these are the various possibilities of A1, D1, A2, D2, right? Like I just wrote 4 of them. There are many more. So like, okay, for this matrix, what is the answer? 2. Like D1 to D2 is 2. Then for this one, the answer is 2. Then for this one, the answer is 6. For this one, the answer is 6. So instead of just counting all the matrices like this, what I am doing is that I am fixing this sum, A1 plus A2. Okay. So like, for these two matrices, you can see that A1 plus A2 is equal to 1. Okay. So if I have A1 plus A2 equal to 1, what does that mean? That means that either A1, A2 is 0, 1 or it is 1, 0, right? So I am just counting all the matrices which have like a 0, 1, and then here they can have anything. But the condition is that the sum should be equal to 3, right? Because I want that 2A1 plus 2A2 plus D1 plus D2 is equal to 5. And since I fixed A1 plus A2 to be equal to 1, so I want that D1 plus D2 should be equal to 3, right? So I'll count the possibilities for this D1, D2. So either it is 0, 3. Actually D can't be 0. So it can be 1, 2. Or it can be like 2, 1, right? So this is for 0, 1. And similarly for 1, 0 also I'll have same. So for 1, 0 I'll have D1, D2 as 1, 2 and also as 2, 1. And then like I can take the sum of that. So for this one the answer is 2. For this one the answer is 2. So 2 plus 2 is 4, right? And from this one also we'll get a 4. Why? Because the D1s, the DI are same, right? The DI value is 1, 2 only and 2, 1. And then this one also it is 1, 2 and 2, 1 only. So basically over all the ways to distribute AI into 1, like what I am saying is that okay, we had two ways to make A1 plus A2 equal to 1, right? Either 0, 1 or 1, 0. So for 0, 1 we have these two possibilities for DI, and for 1, 0 we have these two possibilities, and they are the same actually, like the DI value are same for both of them. So I can simply find out the sum, the required sum for one of them, and I can multiply it by the number of ways to break this x value into A1 say AM, right? So in this case 4 into 2, which is equal to 8. This is what I am trying to get you to understand, that I want to find the sum of P. Like let's say P is, I can define P as D1 into D2 up till Dm. I want sum of P, right? Sum of P over all the different combinations, such that 2 into summation of AI plus summation of DI is equal to n. So what I am doing is I am fixing this AI to be equal to some x, right? And so let's say the number of ways to distribute AI such that A1 plus A2 plus up till AM is equal to x. So the number of ways to do this, let's say it is equal to some P, capital P, okay? And basically so if I have this as x, so what I have is that summation of di equal to n minus 2x, right? So yeah, so now what we can have is, basically if I want summation of di equal to n minus 2x, then what is the summation of this product? Okay, I'll change this name, I'll call it Q. The number of ways to break x into A1 to AM, let's say it is Q. And if I have summation of di equals to n minus 2x, then what is the summation of P? where P was this one. P was this one, right? P was D1, D2 up to Dm. So what is the summation of P if the sum of Di is n minus 2x? So let's say this value is R. So I can simply add Q into R into my answer. Okay. This is what I have been explaining till now. And then I can do this process over all x. Okay. I can do this for all x and I will get my final answer, right? That is my idea. Like I will iterate over the summation of ai from basically 0 to n by 2, right? Because summation of di has to be positive, right? So the limit is n by 2. So this loop will work because the limit of n is up to 1 is 7. So we can actually loop till 1 is 7. So this is fine. But now I just need to find the values of Q and R. Okay. So like I have two problems now. The problem one is the number of ways to break n into a1 plus a2 plus up till am, where each ai is greater than or equal to 0, right? This is the first problem, right? And this is actually a very standard PNC problem. Like if you have given JE, then you must have studied this. Like we can solve this using a method called boxes and like stars and bars, or beggars method, or like there are many names: beggars method, stars and bars, or balls and boxes. So I'll use balls and boxes. Okay. So basically we have to break n into a1 plus a2 up to am such that each ai is greater than or equal to 0, and we have to find the number of ways, right? So like to find the answer to this, we can think of it like we have n balls. Okay, we have n balls and we have to put them into like m boxes. Okay, such that each box has to have positive number of or non-negative number of balls, right? Of course a box cannot have negative number of balls. So basically we have n balls and we have m different boxes, and we have to find the sum of this, like we have to find the number of ways to put these n balls into m boxes, right? So like the number of different ways. So what we can simply think of it like, let's say we have n equals to 5 and n equals to 3. Okay, so like we have 5 balls and we have 3 boxes. Let's say I draw 3 boxes, and let's say I put these 2 balls here, 1 ball here, and 2 balls here. So this is one way. Another way is, let's say I put 3 balls here, then 1 ball here and 1 ball here. This is also one way. So you have to count the number of ways. So now to count this, we can actually think of it like arranging n balls and m minus 1 box separators. Like instead of drawing this diagram, like instead of drawing the diagram like this, I will draw it kind of like this. Like okay, cool. Okay, yeah. So instead of drawing the figure like this, I will draw it like there are 2 balls in the first box, then a separator, then 1 ball in second box, then a separator, and then 2 balls in the third box. So in total 5 balls, and I have 3 boxes. This is the first box, second box, third box, right? So basically I have 2 separators for the boxes and 5 balls, right? And like for this one also I can draw it similarly, that for I'll have 3 balls, then I'll have a separator, then I'll have a single ball, then I'll have a separator, then I'll have a single ball. So this is also a way to describe it. And let's say if I have no balls in a box, if I have 0 balls in a box, then I can also draw it like, let's say if I want to draw 3 balls in this box, no balls in this box and 2 balls in this box, then I can draw it like this, that 3 balls, then this box is empty, and then 2 balls. So basically you can see that all of these drawings are just different arrangements of these 5 balls and 2 separators. Okay, like we have 5 balls and 2 separators, this separator and this separator, and we have to like arrange them, and for each different arrangement we'll get a different way to add these quantities, right? Like if you have 5 balls and you have 2 separators, then in whatever way you arrange them, you will get a new way of breaking the n into 3 numbers. Like I'll just draw a random arrangement. Let's say 3 balls and then this, and then let's say like this. Like if I arrange these 7 items like this, then basically I have 3 boxes. First box has 3, second box has 2, and third box has 0. So 3 plus 2 plus 0. So this is how I can map the arrangements, the different arrangements of these 7 items, and each unique arrangement corresponds to one way of breaking the n into n boxes, right? So I can just count the number of different arrangements of these 7 items, right? Like basically I have 5 items of one kind and 2 items of another kind, and I want to find out the number of different arrangements of them, right? So in total I have 7 items, right? So I can do 7 factorial, but these 5 balls, if I rearrange amongst themselves, they are identical, right? So all the 5 factorial permutations, they are identical, so I can divide by 5 factorial, and also these 2 also identical, so I'll divide by 2 factorial as well. So this is the answer. Like if I have n objects of the first kind and m of second kind, then the number of ways to like permute them is n plus m factorial into divided by n factorial m factorial, right? So this is the number of arrangements. So like in general, if I have a1 plus a2 plus up till am, and I want it to be equal to x, right? Then basically I have x balls and m boxes, right? So like I have x balls and m minus 1 separators, and so I can rearrange them, right? X balls and m minus 1 separators. So to rearrange them, like total I have x plus m minus 1 objects. So x plus m minus 1 factorial divided by x factorial into m minus 1 factorial, right? And actually I can write this like x plus m minus 1 choose m minus 1. Okay, this is also one way to write this, right? Just by the formula of NCR, I can write it like this. Okay, so this is the first problem. The first problem is solved like this, P1. So basically the value of R in this case, the value of Q in this case would just turn out to be x plus m minus 1 C m minus 1, right? Now, so I have found out Q. Now I have to find R as well. So what is R? R is basically so I have one more problem, problem number 2. Problem number 2 is that if my summation of di is equal to x, then over all the possibilities, what is the sum of product of di, right? That means basically let's say m is equal to 3 and n is equal to 5 again. So first of all, how many ways are there to distribute this? There are in total 5 plus 3 minus 1, that is 7. 7c m minus 1 2. There are a total of 21 ways to distribute this 5 into 3 objects. Or actually no, this 21 is including zeros also. Like this 21 includes zeros as well. If you need this di to be at least 1, then the formula is different. Then it is n minus 1 c m minus 1. So in that case it is only 4, right? Or no, actually 6. Okay. So how this comes, I'll tell you that. Like basically I want d1 plus d2 plus d3 to be equal to x, right? Or to be equal to 5, where each di is greater than or equal to 1. So actually I can write the di, let's say di is equal to 1 plus ei, something like 1 plus ei, where ei is greater than or equal to 0, right? So if I put this into the equation, I will get e1 plus e2 plus e3 plus 3 equal to 5. So this is equal to 2, right? And where each ei is greater than or equal to 0. So this thing I already have a formula. So for this the formula is what? 2 plus 3 minus 1 c3 minus 1, which is like 4c2, which is 6. Right, this is just trivia, it is not used in this problem. So yeah, so the problem 2 that we have is if the sum of di, the problem 2 that we have is that if the sum of di is equal to some k, let's say, if it is equal to some k, then we have to find out the sum of product of di over all the different ways to break it. So like let us just look through all the ways to break it. Like let's say m is 3 and n is 5. Then how I can break is, let's say 1 plus 3, right? Or we can have 1 plus 2 plus 2, or I can have arrangements of these like 1 plus 3 plus 1, or I can have, let's say 3 plus 1 plus 1, or I can have 2 plus 1 plus 2, or I can have 2 plus 2 plus 1. So these are the 6 ways of dividing di, right, into 3 numbers. And so for the first division the product is 3, for this division the product is 4, for this the product is 3, for this one the product is 3, for this one the product is 4, and for this one the product is 4. So in total the sum turns out to be 9 plus 12, which is 21. So basically for m equal to 3 and n equal to 5, or k equal to 5, I mean k equal to 5, we have to print the answer 21, right? But now how do I like find out this answer? Because I can't really iterate over all of these different ways to break, right? Because there are in total k minus 1 c m minus 1 ways, and this is like very large exponential, right? So I can't iterate over all of these, so I'll have to find another way to find this 21, to find this sum, right? So how do I do that? Now this, like, okay, like in the contest or while up solving, I solved till here, like till this p1, like whatever I told you till now, I solved till that part by myself. But it was just this p2 which I was not able to solve. Okay, like this problem 2, basically the value of r, like here the value of r I was not able to find out, and so this q into r, like this r I was not able to find out, and I was not able to find solve the problem. So I asked someone, or like I read the editorial, and it showed me a very beautiful way to solve this problem. What is the problem? That if we want summation of di to be equal to some k, then what is the sum of product of di over all such distributions, right? So here also we can think of it like the balls and boxes kind of only. Okay, like the way that we solved this part, that we thought of breaking n into a1, a2 up to am as putting n balls into n boxes, and then using n balls and m minus 1 box separators. So we just counted the number of arrangements of that. So that was kind of a beautiful method, right? So actually we can again think of this one also like that. Okay, like for each arrangement, like in the above problem, for each way of breaking, like basically we want to count the number of ways to break, right? We wanted to count the number of ways to break this n, right? So basically for each way of breaking you are adding 1, right? Like for, if you had this case n like n3k5, then for this breakage you would count 1, for this you would count 1 1 1 1 1, and you would get 6. Like there are total 6 breaks, right? So like for each way of breaking you are counting 1, right? But in our problem, for each way of breaking we are counting their product, that product, right? So like at this point, how do we find the answer then? So there is a very beautiful interpretation of this, that like this, if I have d1 plus d2 plus d3 up to dm equal to some k, okay, and I want the product of di, that is I want d1 into d2 into d3 up to dm, right? So I can think of this value as a physical, like combinatorial thing. Like basically if I have this sum, so I can think of k as the number of balls, m as the number of boxes, right? So let's say I have m boxes, right? I have m boxes, 1 2 3 4 up to m, and I have d1 balls in the first box, d2 balls in second box, d3 in the third box, d4 balls in fourth box, and up to dm balls in the mth box. So this value d1 d2 up to dm, this is just the number of different ways to choose one ball from each box, right? This d1 d2 up to dm, this is the observation, that this d1 into d2 up to dm, this is just equal to, like basically the number of ways to choose one ball from each box. Okay, like if from the first box we have to choose one ball, so there are d1 possibilities of that. Then from second box we have to choose one ball, so there are d2 possibilities of that, and so on until the mth box we have to choose one ball from the mth box, so which has dm possibilities of that, right? So basically this d1 d2 up to dm is just the number of ways to choose one ball from each box. So like, to give an example, let's say we had that example, right, where k is equal to 5 and m is equal to 3. So one way of breaking was 2 plus 2 plus 1, right? And for this we added 4. Okay, for this distribution we added 4 to the answer. So like how do I draw this? Like here I drew it in terms of boxes and like balls and box separators, right? I drew the cases in terms of balls and box separators. So here also I can do that. Like here I have 2 balls in the first box, then I have a separator, then I have 2 balls in the second box, then I have a separator, and then I have 2 balls in the third box, and so I count 4 for this, right? So actually, what is this 4? This 4 is just the number of ways to choose one ball from each box. Like in this case I have three different boxes, right? And from each box I have to choose one ball. So one way would be to choose these two, like I mean this and this, or maybe we can choose this one and this one, or we can choose this one and this one, or we can choose this one and this one. So basically we have 4 different ways of choosing the balls, right? So actually I can draw it in 4 different ways. Like let's say if I shade the chosen ball in dark. Okay, so let's say I shade this ball in dark. So this is one way. Then one more way is to like choose this one and choose this one and choose this one, right? This is also one way. I'll just quickly draw all the 4 ways. Okay, so these are the 4 ways to choose one ball from each box. So like for 2 plus 2 plus 1, we have these 4 ways of shading the balls, right? So actually you can think of it like you have 3 shaded balls, right? You have 3 shaded balls. Then you have 2 box separators, right? And also you have 2 unshaded balls, right? You have 3 shaded balls, you have 2 box separators, and you have 2 unshaded balls like this, right? And you just want to arrange them. Okay, and so all that, but yeah, there is one more thing, that in each separation there must be only one shaded ball, right? Like it must be like there should be one shaded, then separator, then shaded, then separator, and then shaded, like because we want to choose one from each box, right? So we have to ensure that there's only one shaded ball in each box, right? So the order of shaded and separator would be shaded, separator, and shaded, right? So we have 3 shaded balls, 2 separators, and 2 unshaded balls, and we want to arrange them in such a way that like we have to just count the arrangements such that the shaded and separators are alternate, and just we have to count the different arrangements, and that would be our answer. Okay, so like this shaded and separators, the order is fixed, right? So basically we have 5 things of one type and 2 things of another type. So the answer is just 5 plus 2 factorial upon 5 factorial 2 factorial. Okay, so this is the answer. Like this is a very beautiful way of thinking about this, that this product d1 d2 to dm is just the number of ways to choose one ball from each box, and choosing one ball from each box we can draw as shading one from each box, right? And so the different arrangements that we get are basically the number of different ways, and that is what we want. And so to arrange these different items, the number of ways is this. So in general, if I have d1 plus d2 plus up till dm is equal to k, so I have to like, so basically I have m boxes, so I have m minus 1 box separators, right? Then from each box I have to choose one ball, right? So I have to choose m balls, so m shaded balls, and also basically k minus m unshaded balls. Okay, and finally the answer is just like we have basically the order of separator and shaded balls is fixed, right? So this is an object of one type and this is of another type, so we have to like arrange them. So basically we have total 2m minus 1 objects of one type and k minus m objects of another type. So the number of ways would just be k plus m minus 1 factorial, k plus m minus 1 factorial divided by 2m minus 1 factorial into k minus m factorial, right? That is, I can write this as k plus m minus 1 c 2m minus 1. Okay, so this is the answer. So this is the answer for the second problem, that is, this is the value of r. Okay, the value of r is like turns out to be okay, so in terms of k I know, and in this case what is k? K is just n minus 2x. So n minus 2x plus m minus 1 c 2m minus 1. Okay, this is the value of r, and so q into r we can simply find out and add it to our answer. And so for every x we can compute this quantity and then print the final answer. So this was a very nice problem. Like the main observation, like the main beauty of this problem was here, that this d1 d2 to dm is just the number of ways to choose one ball from each box. Because all the other things, they are also beautiful, but they are standard. Like they are taught in JEE. If you did the preparation rigorously, then you must have studied that the number of ways to break n into m is n plus m minus 1 c m minus 1. So that is standard, but this is not very standard, and the derivation of this is very beautiful. So that is the solution of this problem. So I'll show the code quickly now, because of the formula, like for the formula we have, so we'll just have to implement it, and it's not very hard to do that. So I'll show my code. Let's say copy it in VS Code. Oh, not this one. Okay, this one. Yeah, so I have LLNM, CNNM, and I have, like, I make a factorial array to calculate NCR values, right? So factorial and inverse factorial array I make, and I compute them using the for loop, and I have the NCR function which returns n factorial upon n factorial into r factorial, and if the r is out of range I return 0. That is also useful. Then I can just loop from x equal to 0 up till 2i less than equal to n, I plus plus. So this is the value q. Okay, this is the q value, and I plus m minus 1 c m minus 1, and this is the r value. Okay, and so I just do r plus equals to q into r. Okay, and yeah, in the end I also have to multiply by 2 to the power m, right? If you remember, we are only considering the ai less than bi case, but we have to consider all the cases, so we just multiply by 2 to the power m, right? So this is the answer. So this is the solution to the problem number 3, and that was it for today, I guess. Like the problem number C was pretty tough. Like I would rate it at least 2400 or something on Code Forces. So even if you did not understand this, then it is fine, I guess. But if you do want to understand this, then you'll have to practice a lot of PNC. Okay. So yeah, that was the solution, and I guess I will see you guys next time. Bye bye.